Howdy folks, I'm Mr. Ryan, and what we're going to talk about today is called the rules of exponents. Now, a lot of this, if this is not your first time seeing the rules of exponents, it's probably just going to be a review for you, but if you didn't understand them the first time you learned them, then hopefully I can shed some light on those rules today. These rules, most of them are pretty simple. I think the hardest part about understanding the rules of exponents is when you see two different rules that look very similar, you might mix up their rules. So it's important to understand when you need to apply which of the rules. But there's basically, well, there's a bunch of them. I'm going to go over what I call 7 different rules of exponents, okay? So let's go with the first one. Which I call the product of a common base. Product of a common base. When I say common base and when I say product, what I mean is something like this. Let's say that we have some term x to the 5th power, okay? And then we're going to multiply that by x to the 3rd power. So x to the 5th power times x to the 3rd power. So what we have here is, because we're multiplying, we have a product. And because we're multiplying two terms that have exponents, but the base of the exponent in both terms is the same base. That's why I say a common base. So the base of the exponent 5 is x, and the base of the exponent 3 is also x. And because it is a common base, we can actually kind of combine those together, okay? But we're not combining, because combining is more like addition and subtraction. We're multiplying them, but we're putting them together into a single base with a single exponent, okay? Now, when we see x to the 5th power, so let's take a break for a second. I want to make sure that you understand what something like 5 to the 3rd power means. If your teacher gave you a problem that said 5 to the 3rd power, hopefully you would know what to do. This means that you're going to multiply 5 times itself 3 times. So that's 5 times 5 times 5, right? Now, I do want to warn you that whenever you're doing this multiplication, technically there's one more thing happening here. Every product, every time you multiply, every number is all the time being multiplied by 1. So technically, what you have here when you have 5 to the 3rd power is you have 5 times 5 times 5 times 1. Now, when you multiply by 1, you get the same number. But that 1 is going to come up. It's going to be an important thing later in one of the rules, okay? So we know that there are 3 5s being multiplied, okay? Well, if that's the truth, then up here, what this means here is that there are 5 x's being multiplied. That's x times x times x times x times x. That's 5 x's being multiplied. Times, this is 3 x's being multiplied. That's x times x times x. So we have 5 x's being multiplied by 3 x's. So now all we really need to do is ask ourselves, how many x's are now being multiplied? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 x's being multiplied. So this is the same thing as x to the 8th power. And that means that this must also be x to the 8th power. And now we need to ask ourselves, how do 5 and 3 fit together to come up with an 8? Well, if you were to add 5 and 3 together, you get 8. And so the first rule that we're dealing with here, the first rule of exponents is that when you do the product of a common base, you can combine those two bases into one term by adding the exponents together. So x to the 5th times x to the 3rd is the same thing as x to the power of 5 plus 3, which is x to the 8th power, okay? Let's do another example, okay? Let's see what we got here. What if I had y times y to the 4th power? What would that be equal to? Well, you could pause this and try it yourself. The only reason I put this up here is because some people might get confused. Sometimes when someone sees a variable with or a value with no exponent, this is what they say. Well, this one does not have an exponent. And I say, okay, hang on a second. I understand that it looks like it doesn't have an exponent. It does have an exponent, but the exponent is 1. When the exponent is 1, we don't write it on the letter or on the variable. It's the same thing with constant values. If we have the number 4 or the number, let's say 7, if I just write a 7, this 7 equals 7, right? But it's also 7 to the first power. That means that there's only one 7. That's 7 times 1, which is 7. And that's why we just don't put an exponent of 1 on anything when the exponent is 1. So this y does have an exponent of 1. And therefore, if we were to multiply y times y to the 4th power, that would be the same thing as y to the power of 1 plus 4, which is y to the 5th power. Okay? Now, you've probably actually been doing this for a long time. You know, when you had to multiply, let's say, or multiply out binomials sometimes, you'll see an x, you'll have to do an x times an x. And you've probably known for a long time that x times x is equal to x squared. In fact, we just did something like that when we put 5 x's and 3 x's. However many x's there are, well, they're all x to the first power, and then we add them all up. So here, this is y to the first power, and this is 4 y's. This is y times y times y times y. So that's 4 y's, that's a 5th y, and that's why we wind up with y to the 5th power. Okay? All right, let's just do one more here so that you can see something that looks like this. What if you had, let's say 3a to the 4th power b squared, and that this was being multiplied by 3a times b to the 6th power. Okay? Well, here's something interesting. This 3, that's 3 to the 1st power. And this 3, that's 3 to the 1st power. So that's the same thing as 3 squared. Okay? So we could write it as 3 squared, and then a to the 4th times a to the 1st is going to be a to the 5th, because 4 plus 1 is 5. And then b squared times b to the 6th, 2 plus 6 is 8, so that would be b to the 8th power. But do you see this 3 squared here? You could leave it as 3 squared, but you can actually calculate 3 squared. Isn't 3 times 3, isn't that 9? And therefore, instead of putting a 3 squared here, we can just go ahead and put a 9 here. Okay? All right, let's move on to the next rule of exponents. All right, the next rule of exponents is what I call an exponent to an exponent. See, what we have here is we have a to the 3rd power, and then a to the 3rd power is being raised to the 4th power. And now this is different than the one we just did, because we don't have a common base times a common base. That's not what we're doing here. We're doing just a one base, a to the 3rd power, and then a to the 3rd power is the base of this 4th power. Okay? So here's what this means. This 4th power means that there are 4 of these. And that means that there are 4 a to the 3rd powers. So we have a to the 3rd power times a to the 3rd power times a to the 3rd power times a to the 3rd power. Now, if we go back to our first rule, which said when you have now we have 4 common bases. So we really should just add up all the exponents. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So this should be a to the 12th power. And that is correct. Well, how would we get that from this 3 and 4? Well, the rule goes that when you have a power or an exponent to an exponent or a power to a power, you multiply the powers. So this should be the same thing as a to the 3 times 4 power. And so that's going to be a to the 12th power, just like down here. Okay? Let's try a couple more like that. Let's say that we have, all right, let's say that we have m to the 5th power to the 6th power, right? Okay, well, all we have to do here is we have the fifth power to the sixth power, so there's 6 fifth power m's. 6 of these. So 5 times 6, that's 30. So that's m to the power of 6 times 5, or 5 times 6, and that's m to the 30th power. Okay. Now, what if you had one with a number on the inside, or a constant and a variable? So let's say you had 4x squared to the third power. Do you see that? And here's what you have to understand. This 3 now is going to be on, and we're going to see this. This is a separate rule I'm putting on here, but I'm going to give you a preview right now. This third power is going to go on the 4, and it's going to go on the x. So this is going to wind up being 4 to the third power times x to the 2 times 3 power, which is 4 to the third power times x to the 6th power. And 4 to the third power is actually 64. So this would be 64 times x to the 6th power. Okay? All right, let's move on to the next rule of exponents. Okay, this next rule of exponents, I call it the quotient of a common base. See, what you have here is you have a quotient, which means a division problem, right? It's a fraction, and fractions are division problems. It's the top divided by the bottom. And in the top, we have a variable to an exponent, and in the bottom, it's the same variable to an exponent, but in this case, a different exponent. So we have a quotient of a common base. Now, do you remember previously we said that when you have y to the 7th power, or x to the 7th power, whatever, it's this base is that many times. So really, this is the same thing as y times y times y times y times y times y. Whoops, that's an x. That's not a y. Times y times y. There we go. Over, divided by 3 y's. That's y times y times y. So it's only 3 y's. Now here's the thing. Y divided by y is equal to 1. And so what we have here is we could actually split this up into some individual fractions. We have y over y times y over y times y over y. See that? This is 1 fraction, 2 fractions, 3 fractions. Times 4 more y's. Y, and this is all going to be over 1. See, now that we can just multiply a bunch of 1's here. Times y over 1 times y over 1 times y over 1. That's not a, nope, that's a 1. Now, to make it a little bit easier, we could just say times y times y times y times y, and then put all that over 1. Well, y divided by y, that's 1. So this actually cancels out. And y divided by y, that cancels out. Y divided by y is 1, so that cancels out. And all we have left now are 1, 2, 3, 4 y's in the numerator. So that's y to the 4th power divided by 1. And anything divided by 1 is itself. Remember, like 8 divided by 1 is the same thing as 8. 13 divided by 1 is equal to 13. So y to the 4th divided by 1, well, that's just y to the 4th. And therefore, see, look, cancel, 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 and this is all we have left are 4 y's. So this must be equal to y to the 4th power. Well, how can we get y to the 4th power? What can our rule be? If we have y to the 7th power over y to the 3rd power, well, the way that you do that is you do the top exponent minus the bottom exponent. So what this is really going to be is y to the power of 7 minus 3. And so that gives you y to the 4th power. So that's our third rule of exponents. So now, let's say that we have b to the 13th power over b to the 10th power. Well, what we would do is the numerator exponent is 13, the denominator exponent is 10, so this would be the same thing as b to the power of 13 minus 10, which would give us b to the 3rd power. That is our third rule of exponents. Now, Sometimes what will happen is you'll have a larger exponent in the denominator than the numerator. So let's say that we had x to the 5th over x to the 7th. And so what you want to do now is you want to do x to the power of 5 minus 7. 5 minus 7, which will give you x to the negative 2 power. That is an acceptable answer. This is x to the negative 2 power, and that's okay to write down. However, sometimes your instructor may not want you to use negative exponents, and so this is what we can do instead. Another way to think of the rule goes like this. Subtract the smaller exponent from the larger exponent and leave the x in a fraction if the larger exponent is on the bottom. So in this case, we're subtracting 5x's from the top and we're subtracting 5x's on the bottom. That leaves 2x's on the bottom and there are no x's on the top. But remember, everything is multiplied by 1, so that leaves a 1 up top. No more x's, but there's still that 1 that was there. Remember before when we said that 5 to the 3rd power is 5 times 5 times 5 times 1? So when all the 5's are gone, what's still there? There's still a 1 there. Okay, so here, even after all 5 of these x's are gone, the 1 is still there. So our answer would be 1 over x squared. Let me do another one that's kind of like that. Let's say that we have a squared over a to the 10th power. In this case, there's more a's in the denominator, so that means we're going to be over a, and it's 10 minus 2, which is 8, and leaving a 1 up top. Now, what if instead it was 4a squared over a to the 10th? Then the 2 a's would be canceled. This 10 would become an 8, but that 4 is still there. So we would leave a 4 up top. So it would be 4 over a to the 8th power. Okay? All right, that's our third rule of exponents. Let's try another one. Okay, this will be our fourth rule of exponents, and I call this one a product to an exponent. Okay? So inside parentheses, we'll have a product of 2 or 3 or 4 or 5 or 6, whatever, terms. And then outside the parentheses, there's an exponent. And here's where what I call the house of math comes into play. The house of math basically says that exponents live right over multiplication and division. And because exponents live over top of multiplication and division, then you can distribute exponents over multiplication and division. We can distribute this 6 to both the x to the 3rd power and to the y to the 5th power. So that 6 belongs to both the x to the 3rd power and the y to the 5th power. So this is basically the same thing as having x to the 3rd power to the 6th times y to the 5th power to the 6th. Now this refers back to our second rule of exponents that says when you have this, you multiply the exponents. So this is going to be the same thing as x to the power of 3 times 6 times y to the power of 5 times 6, which is going to be x to the 18th power, y to the 30th power. Okay? Or you don't have to do all these middle steps. You can just jump straight to x to the 3rd, 3 times 6 is 18, so x to the 18th. 5 times 6 is 30, so it's y to the 30th power. Let's try another one like this. Let's say that I have a squared times b to the 5th times c to the 3rd, all to the 4th power. And what I would do is, I would do 4 times 2 is 8, so that's a to the 8th power. 4 times 5 is 20, that's b to the 20th power. 4 times 3 is 12, that's c to the 12th power. And I'm done. Now sometimes you'll have a coefficient other than 1 in here. So let's say that you have 5x to the 7th power y squared, and all this is to the 3rd power. So now this third power has to go on the 5 and on the x to the 7th and on the y squared. 5 to the third power, well, that's 125. And then 3 times 7 is 21, so that's x to the 21st power. 3 times 2 is 6, that's y to the 6th power. And this is your simplified expression. Okay? All right, that is the fourth rule of exponents. Now let's go on to the fifth rule of exponents. All right, here's our fifth rule of exponents. And what this is kind of a combination of the first, or no, it's kind of like the fourth rule. It's the rule we just learned. It's kind of like that rule, only it's division instead of multiplication. Okay, so it is a quotient to a power. Okay, so inside of the parentheses we have a quotient, and then it's to the power of an exponent. And it's the same thing. We just said, didn't we just say that because of the, exponents live over multiplication and division in the house of math, that exponents can be distributed over multiplication and division? Well, we just showed how you can distribute exponents over multiplication. Now we're distributing exponents over division. And it's the same thing. This 4 belongs to the numerator, and it also belongs to the denominator. And so this is going to be a squared to the 4th power. So that's a squared to the 4th power over b to the 5th to the 4th power. Now this, according to our second rule of exponents, is going to be 2 times 4 is 8. So that's a to the 8th power over 5 times 4 is 20 over b to the 20th power. Now, you may want to subtract here or something based on the second rule of exponents, or the third rule of exponents that we learned, but you cannot do that because this is not a common base. This is an a, this is a b. They are not a common base. This is done. You're totally done with that problem. So let's say that we had 2x cubed over 4 y to the 5th, and all that was to the 3rd power. Okay? So in this case, we actually have 4 things being, we have division, but we also have multiplication inside of the numerator and multiplication inside of the denominator. And so in this case, that 3 belongs to the 2. It also belongs to the x to the 3rd power. It also belongs to the 4, and it also belongs to the y to the 5th power. Everything being multiplied and divided inside of this parentheses, as long as there's no addition or subtraction. If there is any addition or subtraction inside of this, the parentheses, you cannot distribute this. That's because addition and subtraction, exponents do not live right over addition and subtraction in the house of math. Exponents are on the 3rd floor. Addition and subtraction is on the 1st floor. You can't distribute exponents over addition and subtraction. You can only distribute exponents over multiplication and division. And that's all we have in here is multiplication and division. Therefore, we can distribute the exponent. So the 3 is going to go on the 2. So I'll have 2 to the 3rd power. X to the 3rd to the 3rd. 3 times 3, that's 9. So that's x to the 9th. 4 to the 3rd power, and then y to the 5th to the 3rd. 5 times 3 is 15, so y to the 15th. And then 2 to the 3rd power is 8, so we have 8x to the 9th power over 4 to the 3rd is 64, y to the 15th. Now, you could stop here, and that would be okay. However, a lot of instructors would expect you to then reduce this fraction. Now, it could have been reduced over here with the 2 over 4. That could have become a 1, and that could have become a 2. But over here, 8 over 64, 8 64ths, that's 1/8. So what we would have here is this would become a 1, so we just have x to the 9th over the 64 would become an 8, y to the 15th. So this would be a reduced and simplified version of that problem over there. Let's just do one more. Let's say that we have 5m to the 10th power over p to the 7th power. And let's say that this whole thing is to the 3rd power. So this 3 belongs to the 5, the m to the 10th, and it also belongs to the p to the 7th. 5 to the 3rd power is 125. M to the 10 times 3. 10 times 3 is 30. So that's m to the 30th over p to the power of 7 times 3. 7 times 3 is 21, so it's p to the 21st power. And this is that. Okay? That's the 5th rule of exponents that I have for you. Now let's look at the 6th rule of exponents. The 6th rule of exponents that I have for you is the exponent of 0 rule. Okay, there is a rule where anything to the 0 power is equal to the same number every time, except for there's one minor exception, but you shouldn't have to deal with that in this class. Okay, so what is 4 to the 0 power? I encourage you to look that up on the internet. Maybe you should figure it out. But I'm going to show you why the answer to this is what it is. And here's the answer. Anything, no matter what, number or variable, x to the 0 power. 4 to the 0 power is 1. X to the 0 power is 1. Anything to the 0 power is 1, except for 0 to the 0 power. We don't do 0 to the 0 power. That's an indeterminate form. We're going to leave that alone. Don't even ask about it. I just wanted to let you know, if you ever saw 0 to the 0 power, that's a special case. It's like a black hole or something. All right, so 4 to the 0 power is 1. X to the 0 power is 1. Why? I'm going to show you why. Because, remember let's go back to, I showed you an example a few minutes ago where it was 5 to the 3rd power, and we said that that means 3 5s. So that's 5 times 5 times 5. But I also told you that there's also a 1. Every multiplication product, every multiplication problem always has a 1. All products are always being multiplied by 1. There's always a 1 included in there. Okay? So, 5 to the 3rd power is 3 5s, 5 times 5 times 5 times 1. Because what the exponent means is this. An exponent means include this number this many times in a product. So, if I have 7 to the 19th power, what that means is include 7 19 times in a product. And then you would multiply by 1 at the end of it, because 1 is always included in a product. Well, then what would 5 to the 2nd power be? That would mean include 5 2 times. So that's 5 times 5, and then times 1. What would 5 to the 1st power be, which really is just 5? That's include 5 1 time times 1. Well, then 5 to the 0 power would simply mean include 5 0 times, include 5 0 times, but the 1 is still there. That 1 is still there in the product, and therefore anything to the 0 power is equal to 1. Okay? So, that means that 9 to the 0 power is also 1. But let me show you what else it means. What else this means is, what if you had y to the 7 minus 7 power? Wouldn't that equal 1? Because that would be the same thing as y to the 0 power. Which is one of the reasons why. It's one of the reasons why y to the 7th power divided by y to the 7th power is equal to 1. You want to say it's because the top is the same as the bottom, and whenever you divide the top, whenever you divide a number by itself, you get 1, right? Well, look at this. Isn't this y to the 7th over 7? Based on the rule we learned, rule number 3 of exponents, wouldn't we subtract the top exponent minus the bottom exponent? So this would be the same thing as y to the power of 7 minus 7, which would be y to the 0 power, which is equal to 1. So you want to watch out for the problems where it doesn't actually just give you 0, but it gives you something that would give you 0. And I'll show you something like that right now. Let's say that I have x to the power of k times x to the power of negative k. What if I have x to the k power times x to the power of negative k? Well, based on rule number 1, it's a product of a common base. We're going to add the exponents. So we have x to the power of k plus negative k. Well, what is k plus negative k? That equals 0. And so this is the same thing as x to the 0 power, which equals 1. What if, however, I had a number in front of it, a coefficient? What if I had 17m to the 0 power? Well, it's not 1, that's for sure. What's m to the 0 power? That's 1. And what's 17 times 1? That's 17. Okay? Or what if I had 4 times a to the negative 5th power times a to the 5th power? Well, a to the negative 5 times a to the 5th, if we add negative 5 and 5, then we're going to have 0. This will be a to the 0 power. 4 times a to the 0 power. And a to the 0 power is 1 times 4 is 4. But what if I had 8 to the 0 power times x to the m power times x to the negative m power? Well, now 8 to the 0 power, that equals 1. X to the m power times x to the negative m power, that's x to the 0 power. So that's 1 times 1. So the answer there is 1. So sometimes it gets sort of clever and annoying and tricky in these problems. So watch out for that. But the basic rule is anything to the 0 power is equal to 1. Okay, our last rule of exponents, the 7th one, the last one that I'm going to teach you anyways, or at least in this lesson, is the rule of negative exponents. So, anytime you have a negative exponent on a base, all negative exponents mean is that you have a fraction. You're dealing with a fraction here. You have to turn it into a fraction. See, this negative exponent means that this number is on the wrong side of a fraction line. See, this is actually the same thing as 4 to the negative 3 power over 1. And I know that because if you take any number like 6, 6 is the same thing as 6 over 1. You can take any mathematical expression and turn it into a fraction over 1, and it still equals the same thing. So 6 is 6 over 1. 3 to the 7th power is the same thing as 3 to the 7th power over 1. And therefore, 19 to the negative 2 power is the same thing as 19 to the negative 2 power over 1. And so that also means that 4 to the negative 3 power is the same as 4 to the negative 3 power over 1. Here's basically what a negative exponent means. That negative sign in front of the exponent means move me to the other side of the fraction. This negative sign is saying move this 4 to the 3rd power to the other side of the fraction. And so it's saying to put this down here. Now if I put this down here, there's nothing left up top. And when there's nothing left in a division problem, it leaves behind a 1. So there should be a 1 left up top, and this 4 to the negative 3 goes on the bottom. But because it's switching sides, it's not a negative exponent anymore. We're going to get rid of the negative. It's just 4 to the 3rd power. So this is the same thing as 1 over 4 to the positive 3 power. And 4 to the 3rd power is 64. So this is really 1 over 64. All right, so what if I had a variable? What if it was x to the negative 5 power? Well, that just simply means that this is going to become a fraction of 1 over x to the 5th power. Y to the negative 9 power becomes 1 over y to the 9th power. M to the negative 1 power becomes 1 over m to the positive 1 power. But we don't write the positive 1 power, we just say 1 over m. So x to the negative 1 power is just 1 over x. A to the negative 1 power is 1 over a. And y to the negative 1 power is 1 over y. Okay? It just means turn it into a fraction. Now, what happens if it's already a fraction? What if it is already a fraction? What if you have 1 over b to the negative 2 power? 1 over b to the negative 2 power. Well, this negative means move this to the other side of the fraction. So it should be moved up to the numerator. So this is going to become b to the positive 2 power over 1, because it's going to leave a 1 behind. And anything divided by 1 is itself, so this is just b squared. Now, if there was a number in the denominator with it, what if we had 1 over 7x to the negative 3 power? Well, the 7 does not have a negative exponent, so the 7 is going to stay in the denominator. And it's only the x to the third that's going to move to the numerator, and it's going to become x to the third power over 7. If you practice with these rules of exponents, in fact, it would be good if you practiced a lot with them, if you found like a website where you could practice with them, you would get so good at this that once you got to higher levels of math, you would be able to manipulate equations using this rule of negative exponents, okay? Well, that's all I have for you, the rules of exponents for today. There's a worksheet, you work on that, you can check your answers, and I'll see you in the next video.